So you'll recognize some of the circuitry from my previous video, but what is new is the laser cut enclosure. I did this out of cardboard because there were a few issues that I didn't know about that came out from actually putting this together in cardboard. So it's a great idea that I took the time to do that because I messed up things like forgetting to make this cutout right here. These holes weren't the right distance apart, so I definitely needed to know that before putting it all together. And so I adjusted my drawing and just now laser cut all of the pieces out with the correct dimensions, and now I'm going to piece them together into a final product. So I've started replacing the cardboard with the MDF cutouts, and it's looking pretty good. So here's the main board and some spacers in there, and you can see the display and the encoder. And so I turn the encoder clockwise and the frequency increases. So it's looking pretty good. The electronics are working out pretty nicely. I went for the encoder partly because I wanted the freedom to be able to play around with this using programming. Maybe changing the, being able to continue rotating the knob and getting an increasing frequency. And so just giving me some of the flexibility later on to decide exactly how that works. All right, so let's keep going. Assembling these pieces together, I just want to point out it's really slick. I had a student actually discover this option on the MakerCase website that you can put in a T-slot, and essentially there's space for the screw and a nut to just go right in there and hold the two sides together. So for something like MDF, where you're not going to screw these two sides together with like a wood screw or something, this is a really nice solution, and it's making it so that as this comes together, if I do need to get in here later on and fix something, it's a matter of taking a couple screws off as opposed to breaking glue or doing something else. So this is really nice. All right, so that's the last view of everything inside before I seal it up. You can see I have the output wires coming out through those holes in the side. I have my wires just with masking tape for now, held in place for the encoder and for the display that's in there. And I've left this little notch as a strain relief to make it so that if the power cord gets pulled, it's actually pulled against this this plastic piece here so that it's not yanking on the wires directly. So everything's looking good. Let's seal it up. All right, so here it is. The power supply, they're on the floor, so we have a nice long cable, so it's just this on the table, and these are the output leads. We would connect this to whatever we want to flash at the frequency. You can see I've actually cleaned up some of the programming so that we don't really have any flashing happening on the screen. I did that by making it so that it only updates the screen when the encoder is turned. So as we click that around, frequency goes up. Click it the other way, the frequency goes down. There is a little bit when you try to turn it way too fast, it almost skips some of the frequencies. So that could be something that we play with and really finely tune. But right now it's looking pretty good, and I think it's ready to actually connect up to either a light or the wave generator and see what we get when it actually runs.